The development during the intellectual revolution showed changes in the way people think about the world, and the improvement of life brought about the science and technology. This period is also known as the scientific revolution. Though there were other scientists who became known during this era, we will focus only on the three important intellectual revolutionists in the history. Through this session, you will be able to demonstrate understanding on how Copernicus changed ancient beliefs on astronomy, distinguish the differences between fixity of species concept and the theory of natural selection of Charles Darwin, explain how intellectual revolution transformed the views of society about dominant scientific thoughts. For your performance task, you are to prepare a 15-minute podcast about the work of Charles Darwin, discussing the theory and give concrete concepts of evolution, natural selection, and adaptation. Sigmund Freud's level of awareness, conscious, subconscious, and unconscious mind. Sigmund Freud's personality components, id, ego, superego. To be followed by a long quiz. Intellectual revolution refers to a series of events resulting to modern science and birth of scientific thinking across periods in history. It involves two-stage process of discarding the old and believing the new. It is worth noting that these revolutions are in itself a paradigm shift, a shift that would make us better understand how the universe behaves and functions. It challenges long-held views about the nature of the universe, thus making it controversial. Copernican revolution refers to the 16th century mathematician and astronomer Nicholas Copernicus. Copernicus tries to contradict the existing view that the Earth is the center of the universe, as Ptolemy illustrated. In the geocentric universe, the Sun, Moon, and other planets revolve around the Earth. His geocentric model was held for 1400 years. There were several assumptions under the geocentric universe. Number 1, the Earth is the center of all motions, that everything will revolve around and move towards the Earth. Second, that stars are immutable and will continue to exist forever, that there is no such thing as death of a star. Next, that planets move in circles, not elliptical orbit. The geometry was so perfect according to them. That the Earth is flat because the horizon is flat, and if the Earth is round, just like the rest of the heavenly bodies that they saw, then they would fall off. Remember, there were no physical laws yet existing during these times, no concept of gravity or law whatsoever. Lastly, that the Earth does not move. It's the sun that moves because that is how they see it. Aside from that, they don't feel the movement. We all know that when a car is moving or not when we are inside it, right? We feel it, but not the movement of the Earth. And so they believed it. Geocentrism was later refuted by Copernicus when he introduced heliocentrism. In his model, he positioned that the Sun is at the center of the solar system. He said that the Earth rotates in its axis as it revolves around the Sun together with other planets. This gave birth to modern astronomy. It later inspired other astronomers to question their early beliefs on outer space and celestial bodies, the era that was known as scientific revolution, since it resulted to transformation of thoughts and beliefs. Copernicus' idea was met with a lot of resistance, primarily from the church. It was unthinkable for them to put other things and not man as the center of all creation. He was declared heretic, an enemy of the church for contradicting beliefs about the earth and the universe. He acknowledged the fact that the position and motion of planets and other objects in space could be estimated through systematic data gathering and interpretation. Though there were struggle and confusion during this time, there were also several scientists supporting the Copernican theory. One of them is Galileo. When Galileo discovered the moons of Jupiter, he tried to oppose the assumption that everything revolves around the Earth since these moons revolved around Jupiter. When he discovered the presence of sunspots, all moving in the same direction, he concluded that the sun is moving in its own axis and so is the earth, but his analogy was not accepted that time. Then he observed the phases of Venus, and its size changes from a very small full face to a gradual increasing size till it was seen in its crescent phase at its biggest size. That is when he concluded that the size of Venus is bigger when it is closer to the Earth and smaller in its full phase because it is in the opposite side of the orbit. That Venus will have the same size in all its phases if it is revolving around the Earth just like the Moon. But since it is revolving around the Sun, we can see the full phase when it is on the opposite side of the orbit and becomes bigger as it approaches the Earth, thus rejecting the assumption that the Earth is the center of all motions. Tycho Brahe is known for his skills in making astronomical instruments. Brahe proposed a model of the solar system that was intermediate between Ptolemaic and Copernican models. He said that as the sun revolves around the Earth, the other planets are moving around the sun. Brahe's ideas about his data were not always correct, but the quality of the observations themselves was central to the development of modern astronomy. The most significant was when he was able to observe an explosion of a star, a supernova. This rejected the assumption that stars are immutable. Johannes Kepler is a great believer of the Copernican model in placing the sun at the center, until when he was able to formulate the three laws of planetary motion, proving that the orbit of the planet was not circular but instead an ellipse, thus rejecting the assumption of circular orbit of planets. Isaac Newton is known for his universal law of gravitation and the three laws of motion. This is different from Kepler's three laws of planetary motion. When Newton formulated the universal law of gravitation, he explained that the reason why we are drawn toward the Earth is due to gravity. Albert Einstein is known for his theory of relativity. Energy is equal to mc squared. That other striking consequences are associated with the dependence of space and time on velocity. At speeds near that of light, space itself becomes contracted in the direction of motion and the passage of time slows, but we're not here to discuss that. Using Einstein's theory that motion is relative and not absolute would explain why it appears like it's the sun moving around us and not the other way around because we are inside the system. Even the movement of the Earth is not felt because our movement is relative to the movement of the Earth. Prepare for the group presentation of your podcast about Charles Darwin and Sigmund Freud next meeting.